G'day guys, you're back with MiracleMAX. Well, she's going to be a scorcher today. Kind of warm in these Reynolds. The mercury is going to head way up to the 40-degree mark, and that's way hot. And in this little workshop that I'm in, it gets even hotter. There's not much airflow. That being said, today's project is exactly that, getting some airflow happening. Now there's two main sources of airflow that I have in my little workshop. I'll show you the first. The first one is a little industrial fan that sits on the ground. While that's great, you need more airflow in this workshop. The second one is today's project. Let's have a look at that. And the second form of cooling that I use is this evaporative air conditioner that, believe it or not, I picked up off the side of the road during a hard rubbish day. It worked fine apart from, not so much today. Let's have a look at it. And for those playing along at home, it is a Mistral, catalogue number MACH60. So it says do not immerse. I don't know too many open electrical things that you are allowed to immerse. So common sense should dictate there, but hey, you've got to write it down so you don't get sued. Let's get on with the repair. I wasn't going to make a video on this, but hey, you know me, any excuse for a video. It's a hot and cold device, so we've got heating as well as cooling in it, which is excellent because I can use it during the winter as well. So fairly easy operation. We have a button on the side, it's our main power supply. We've got an on button up the top. And now we have fanage, all very nice. We have extra buttons here, hopefully you guys can hear me over the top. You can put it on cool and all sorts of stuff, so we've got our cool button there. You can see the little LED on. There's also a flow button. Now the flow refers to the evaporative side of things. I'll show you what I mean at the back. So when it's in the flow phase, this mesh here goes around and around on rollers, as you can see, and the bottom section sits in the tray of water here. In actual fact, you can put ice in it as well. It makes it nice and cold. So as this rotates, this goes round and around, it picks up the water and the moisture stays in here, and the fan goes through it, blows across it and creates an evaporative effect, therefore cooling the system, or cooling you hopefully. But unfortunately this flow system is not working at the moment. It's not rotating. Now how it works is right up the top here you can see a little hole there with a slot on it. So it's got a little electric motor here that has the slot on it, which in turn fits into that slot there. Now the problem is when I put it on flow, and just have a look and see what it's doing. Okay, we've got it on, flow. Okay, what do you notice about this motor? Well, nothing. It's not working. That's the reason behind this video today. So let's do some testing and figure out, is it the motor that's faulty or are we missing a power supply? As I always say, if you're going to do some testing, make sure that you have the power cord right in front of you so that you can see that it's disconnected, therefore the system is powered down. Make sure if there's any capacitors, high charge capacitors, that they have been discharged as well before you do any testing. For now, I'm just going to have a quick visual, see if anything's wrong. You're probably thinking to yourself right now, well, this is all well and good, but how do we test this motor and what do I put my multimeter on? Well, fortunately, there's a sticker stuck on the little motor. If you can see it there, it says 220 to 240. Well, here in Australia, we're 240 volts, and that is AC, of course. It's a synchronous motor. So we know we need to put our multimeter in the AC range, just up here, not the DC, but the AC, the wiggly one, and we can check for 240 volts when it's powered up. So let's see if that's the case. Here's the little motor that we're working on. Chucking to one side, follow the loom, there we go through. We can see that it's brown and the other one is blue. Now I've got my multimeter probes connected already, and let's see what it's reading when I fire up the flow button here. So by rights, if I turn on my power, turn on my main power and this power, and then hit the flow button, we should see voltage. At the moment we have, I know that my connections are good because we're reading like a ground circuit there, but if we press this we should see 240 volts, but we're not, are we? we definitely have an issue here of some description. We're only saying 0.015. With that being said, when we turn on the flow side of things, you can see the little LED comes on. I'm not sure if you can see it too well, but the LED is working fine. So we know that that side of the circuit is okay, but for some reason we're not getting our high voltage off to our little motor. Disappointed! So before we get all excited and start pulling stuff apart, let's just start with some logical thought process, shall we? Now, we know that this thing here, let me get my little motor up. So here's my motor, isn't it? Okay, that's that black wire loom here, and that's made up of two wires. One will be brown and one will be blue. Now the brown wire is our active wire. That comes straight from our power supply, and our return or our neutral will be this blue one here. Now let's just logically think about stuff for a second. Now you can see that this one here, let's just put our neutral aside for a sec, our active is connected with two other ones, a black wire and a blue wire. I've traced that black wire down, and that actually feeds the main fan, the big fan, that big sucker that spits out all the air. Now think about it, if the fan is working, then obviously this must be working too, correct? Well, that makes sense, doesn't it? Our active at this point in time, I believe, has power going to it. This bloke over here, this is the other side of the supply to our little motor, and we can see that it has a blue wire here and a purple wire. Now if I was to grab those two wires, the active and the neutral, and shove them straight into a power supply, or into the wall, which I wouldn't do, but if I was, I believe that that motor would work okay. Now what's this purple wire? Well, that must be a switching wire. So when I press my button over here, my flow button, that should power up here. This in turn would, or supply the return side of things, or the earth side of things, in through this wire, through the motor, through the active here, back through, returning through my motor, down through my switch, and then back to neutral. Okay, so I believe that this is the wire that we must be chasing. Let's have a look at that a little further. Where does that fella go? I reckon it's on this little power supply here. We can see it's got some relays on it as well. That is doing some switching, probably from our switching over the front here. This would be done through low voltage, I would assume. Then it gets ramped up, most likely through some relays there. So I believe that's where I should look at next, perhaps this little power supply, try and trace where this purple wire goes next. I've just pulled the circuit board up, as you can see, and this is the purple wire that we were tracing. This is this little fella here. Now, they've very conveniently labelled some of these transistors where the wiring comes in. Unfortunately, they're soldered to the board, so it's a little bit hard to separate the circuit board at the moment from the actual appliance. But we can see that they've labelled. So we've got, what's that, mid, I think, high, swing, cool, and what's that say? No? On? Maybe it's on, I don't know. But either way, this little purple wire is coming up here. Now, whether it's classified as swing, there's no actual swing feature on it, but whether it's, well, I've just got to follow this purple wire basically, flip the board over, have a look and find out why we're not getting power to our little motor. As you can see, there's a series of transistors here that line up all together with resistors right next to them, of course. Now, I've got the part number written down, but just for your benefit, look, I don't know if you can see that through the camera or not, but it is in fact a 0607 V89S, and all of those transistors are identical. So the testing procedures should be the same, shouldn't they? All of them have the same resistor all the way through, bar this fella over here, but I've tested all of those resistors, they're fine. But these two transistors are giving me some dodgy figures, so I might pop them off board and have a check of them while they're off board. You'd have to agree that one of the most frustrating repairs, diagnosis of a problem, is when it's intermittent or you accidentally fix it. Now, I think I might have accidentally fixed it. I don't think I did on purpose, that's for sure. What I've done so far is, first of all, let's just put that fella there, so I have no power going to it. So what I've done is, I pulled off two of these what I thought were transistors, but they're actually triacs, which form a transistor, I guess, anyway, and tested those. They had some strange readings, but they were consistent with both of them. When I pulled them off and I tested them with my little homemade tester that I've made, they tested okie dokie. So, well, I've got nothing connected, that's why. Both tested okay. So I put them back together, and guess what's happened? I'll show you. So if you're wondering what that panting noise is, it's my dog Russ. He's a bit hot, and he decided to join me in the workshop here to try and get a little bit of cool. Perhaps he's envisioning that I might fix this evaporative conditioner cooler, and he can enjoy the cool as well. Say good day, Russ. Hey. Okay, so I've placed the obligatory piece of tape on a rotating component just to show the video that, hey, it's working. And this is what I've found. Let's power it up, power on, let's hit it some cool, and then let's hit it some flow. And around she goes. Round and round she goes, where she stops nobody knows. Yep, just a little bit frustrating. It's good that it's going, but I would have liked to say, hey, this particular component was faulty, and you know, I've now replaced it and it's up and running. That would have been fantastic. But I don't know. Was it a dry solder joint at the triacs? I don't know. But it's working. That's all that matters. I'll leave it running for some time and just make sure that that continues to work. But hey, a little bit frustrating. But as long as it works, I can remain cool in the workshop. Well, really, it should have been a bit of a giveaway to find out that they were triacs. It's actually printed on their TR6, TR5, etc. We're looking at 5 triacs, 1, 2, 3, 4, 5, and that corresponds to 1, 2, 3, 4, 5 switches on the front. So these triacs are interesting fellas. They're called triode for alternating current. That's what the abbreviation triac stands for. And it's a bidirectional triode thyristor, so that fast 3 times. And it's also related to the silicon-controlled rectifiers. Now these fellas are a thyristor. They're made up of a gate, an A1 and an A2 outlets, terminals if you will. I've already proven that the flow side of things is working. I think they listed on the board as a swing, but the button on the top says flow. Now I know that it all works, but how does it actually work through the triac? And how can we test it on board? What I've done here is I've just put my negative side of my multimeter onto the cathode of a diode down here. So that's the negative side of things. And now we'll have a look at the triacs and just see if we can measure them. The gate is this center leg here, this fella here. Now I'm probably going to have a bit of trouble trying to show you the multimeter while I'm testing. I'll give it a whirl and see what happens. I'm going to struggle to show you exactly what I'm doing, but fingers crossed I can do it. So we turn the power on. Now, the cool button is not turned on at present, so the gate already has power to it, I believe, yes. And A1 has got power to it, but A2 does not. So let's press the cool button, and we have power going through that A2. Let's have a look at our swing. Now remember, the swing is the one that we're looking at, and we want to make sure that that is not turned on at the moment. So our swing should have power at one side there, which it does, and our center one should have power, but the outer leg should not at this point. And I'll turn the button on, and there we go. So I know the other triacs are working, so just testing those two, the cool and the swing, they were the ones that I tested before that I wasn't happy with. I know that those triacs are working correctly. They're basically like little baby relays, if you will. So just looking downstairs there, my little motor is still turning around after, 2 hours? So I'm pretty happy with those results. So it's been over 2 hours since I did this repair, and I'm very, very happy with the results, as is the motor. Yeah, look, I can't say exactly what the fault was because it's working. Was it a dry solder joint? I don't know. But those triacs are working, I've tested them, and after 2 hours of operation, this is working fine. Time to stick it back together, get some coolness in this workshop. Just to give you an idea of how the system works, this is the little motor that rotates this matting, I guess you could say. that wasn't working before, and if we hit our cool and flow button, you can see the matting's now rotating, and of course that goes into a big tub of water, and that brings it up and around. The motor circulates the evaporated water that then cools you down, hopefully. Anyway, that's the basis of it. We'll stick it back together and see if we can get some coolness out of it. Sweet. And if you're after the full Arctic experience, you just chuck in some ice. Oops, man overboard. There we go, fire up. That'll melt over that matting and it'll cool down as it goes through and transfer some of that coolness to you. So you can see the rotating matting doing its job. It's going around and around. I did lubricate these points as well to make sure that they were in good condition. I used a silicone grease, which is acceptable in water. So give it a little bit of time, and she's icy cold out the front, mate. The little evaporative air conditioner is now up and running. In fact, it's been running for over 4 hours. There's a chill in the air. Who am I kidding? I'm sweating like a schmitzer in this stuff. Who thought of this? Max, what the hell's wrong with you? Even though it's nice to have this little evaporative air conditioner up and running again, still hasn't put a dent in the 40-degree temperature of today. While this wasn't a record-breaking repair today, guys, I hope this has given you some sort of idea of how to test a triac and to do some basic diagnostics. It seems there might have been a bit of a dry solder joint at that triac that was on the flow circuit, which turned the motor, that rotated that mat, drawing up the water, therefore cooling you and me. I hope you enjoyed this video, guys. If you haven't already, please subscribe to the channel, give it a like, feel free to comment down below. Hey, don't forget about that notification bell so you don't miss any future videos. Until next time, this is MiracleMAX signing off. I will catch you later.